a few minutes for people to join in. We are seeing people are still joining in. So we'll just wait for around 3 to 4 minutes before we begin. Ravindra, we also have Tushar, who is going to present a few slides. We will talk about the agenda and facilitated by Sonika and Arun. This session is about well-architected review plus. All of you, or most of you would have gone through well-architected review process, but if you want to cover holistically, how would you look at the architecture best practices from different workload perspective? That's going to be the idea. I would encourage you to have all communication to us via chat box to avoid any additional background noise. And please, enter your questions in the questions tab below. Thank you. Yeah. So this is a quick agenda for the day. We will have a quick introduction round followed by some housekeeping. Once that is done, we will have a quick poll. We will be using Kahoot for a few polls and quizzes. So it's highly advisable that, if you can have a second device like your mobile or something ready where you can access the poll, that would be great. After that, we'll cover the essence of what a good architecture means and run through the well-architected principles, followed by a quiz. It's there. Tushar will lead discussions on the serverless lens. And throughout the session, what we'll be doing is we'll be taking one case study as a reference line, not necessarily that is the only case study. But just to keep things, in the context, in the frame of reference, while we are discussing, we have picked up a simple web application as a case study. We will run you through that. We'll have a closing quiz and a wrap up with some, call to actions and few takeaways. Again, please feel free to use, the questions. Keep on sending those questions, and the panelists will be happy to answer those questions. The presenter today are myself, Ravindra Ved, and Tushar Agrawal. So I will be covering the well-architected core pillars. Tushar will be covering the serverless lens. And the panelists to help us, to help us for the questions are Sonika and Arun. Quick housekeeping here. Strictly, this content is under NDA. For the partners who have registered, they are only having access to this webinar. So this is, a content under NDA. Just note, this session is not being recorded. Any questions, again, feel free to put it in a chat box. We will have a lot of quizzes to keep this section more interactive. We'll be using Kahoot for quiz. For any reason your system times out, you can just hit a refresh in a Kahoot, or you can join back with a game pin. We'll be sharing the game pin as we get along on the session. Finally, towards the end, we'll like to get your feedback on how the session went. And yes, we all are working from home, so we might face some network issues. Just in case one of the presenter drops off, we request you to just hold on for a while the presenter logs in back, or if there is some the other person who can just pick it up. So in case of any network issues, please have patience, hold on for a few minutes. Having said that, just moving along, and just wanted to know the audience here, right? So the idea here is to understand the audience, the people who are participating in this forum, so that we can contextualize our session accordingly. That's the idea behind it. I'm just going to start a quick poll. Just give me a moment. Got it. We request you to log into kahoot.it and use the following game pin. Uh, we have 45 players joining in. We have a total of 140 attendance right now. Okay, we'll wait for another 30 seconds before we open the poll. I hope everybody will get a chance to log in. We have about 150 participants. Perfect. 10 more seconds. So it's just one question to understand what is your primary role. Okay. Yep. I'm starting the question. Awesome. So here we see the results. Thank you. This helps a lot for us to tailor the content and take a specific example. So we have got 73% of solution architects on this call. We have got a good mix of software developers, senior exec, and DevOps engineer. This really helps. Thank you. We will just move along to the next slides. Okay. Um, so we have solution architects on the call, which is the maximum majority, which is great. We also have the software development team, the executives, and DevOps engineers. The quick question here is, okay, why? And I'm sure most of you understand why it is important to have some form of mechanism to capture the architecture, right? And it's not just about the theoretical way of capturing an architecture. It's about capturing the essence of an architecture that you want to build. Right now, while you are doing that, what are the key things that you have to think through? Right, being in the partner organizations, the team members over here, every day in day out, you come across different workloads, right? So there are diverse workloads that team comes across. There are various teams within your organizations that work at in the migrations project. There are some team members who are working on a modernization project. Some are building digital native applications or cloud native applications. A few teams are working on data analytics and machine learnings aspect of the same application or for different applications. So the essence what we are trying to say here is that we all work with diverse workloads. Each of these workloads, irrespective of what delivery methodology that you use, agile being the most prevalent, being used by the delivery organizations, has to still go through the same phases of planning, analysis, design, implementation, testing, and maintenance. Right now, as you go through those standard cycle, what we just do is we just compress them in iterations or in sprints. But we still have to go through that, right? And when you do all of these, it is important that you need to understand the overall big picture, right? Whether you are migrating a workload, so you need to have a big picture in terms of how are you going to migrate, what are the dependencies, what are the priorities, which application you will take for modernizations. If you're building a grounds up greenfield application, what are the system components, a few of these questions may be related at the very top from the business to the IT Connect point of view. So now I'm sure most of you would have heard of the standard enterprise architecture frameworks like TOGAF or integrated architecture frameworks. So whichever frameworks you have a mental model in your mind that how are you going to have your traceability right from your business requirements to your technical infrastructure to your application modules and functionality, right? So just giving you a glimpse of some of the questions that you want to ask or you might get asked by the customers, right? In different scenarios. The first scenarios is, and these are just the sample questions, by the way. This is by no means an exhaustive list of questions, but just to set a context and get the ball rolling. A few set of questions that are important. Let's say, for example, you are in a top-down approach, right? You are developing a greenfield application. Now, when you are in a greenfield applications, the questions that customers may ask you is that how do I define the custom architecture? The requirements are sketchy. We kind of don't understand how this product or how this particular feature is going to evolve, right? But then how do we have an evolutionary architecture so that it evolves along with the requirement changes? How do we decompose the cross-cutting concerns? This is very important. If you look from a software development point of view, or from a system engineering, a DevOps perspective, or a solutions perspective, you have cross-cutting concerns throughout your application, be it the application logging, monitoring, even standard user features like sign in, login credentials management, serving some static content. So these are the cross-cutting concerns. How do you assemble them from a top-down perspective? When you're doing a refactoring or application modernization perspective, what you get is you get a view of only one application, and then you have to think, okay, I got this application, I'm working on it, and I'm going to get two more applications, but how these applications all, or these components that we are migrating right now, all combine together into a high level big picture, right? What mechanisms do we have to assess each of these components so that as we migrate, we have a consistent process, or as we modernize, we know what areas to look and focus for. Different kind of workloads is that once you have either a greenfield or a refactoring done, you are now ready to go live. And the questions that you will be asked is that, how do we know that we are ready to go live in production, right? Have we thought of all the risk? Do we have a mitigation plan in place? Business continuity planning, right? Nobody would have ever thought that how important business continuity planning is unless 1 month back, where things suddenly change and everybody had to work from home, right? This is all about how fast you're able to adapt to the changing environments, right? Um, these we'll talk further in down the line. Is automation is the key kingpin or the underlying glue that binds all of these things together, right? As you're going into and maintaining your applications, you need a right set of metrics to understand, okay, what are the users using, what are the user consuming, are there any specific trends that I'm missing that we can look into and rather do a preemptive maintenance, or we can have announcement of a specific service or a releases. And again, as you make all these changes, how am I able to keep track of this evolving architecture? Because that again becomes one of the very important things, being able to track as architecture is evolving, right? And finally, the executives will ask you questions. Hey, okay, you migrate application, you create a new application, already running an application. Tell me, help us understand where should we invest further. Okay, I want to know that, are we following all the best practices? Are there any risks that we have not seen, or are we tracking the risks so that we know how they are changing over time? This is essentially why the reviews, or well-architected reviews, or any architecture reviews, is never a one-time process, right? Things change over a period of time, things evolve, and you have to re-baseline, revalidate, and any assumptions, any decisions that you have made. Things change, new services comes, evolution happens, and this is just a continuous process. Having said that, it again becomes more important for us to understand in the context of how, as of today, you are capturing the architecture, right? And there are different ways, right? Many times you get into a meeting, you open a piece of paper, you just start drawing diagram, you use whiteboards. People who generally come from software development backgrounds, they would create a UML diagram or an ER diagram, right? People who come from a TOGAF background, they may have a TOGAF, the mental model of around 8 blocks, or you can use C4 model. So what we want to do quickly here is spin up another poll, and what we want to do in that poll is that kind of understand what is a mechanism that you are using right now to capture the architecture within your environment or within your workload. That is the essence that we want to capture right now. Just give me a moment. What I'm going to do is I'm just going to start another Kahoot poll. So please be ready with your devices. I'm just going to pick up another poll in a moment. So you're going to have 3 questions here, and I'm just starting it off. Yep. Perfect. I request you to join this quiz and help me understand what mechanisms you guys are using right now to capture the architecture. So we now have a total of 175 participants, and I believe everybody would have the setup on some device working. Great, we already have 98 players in. Great, we'll wait for another 30 seconds. Come on, we already have 113. Great. We need 50 more participants to join quickly. Thank you. Okay. Ready to start? Okay. Here's the question. That's great. So we have whiteboard. Yes, that is always the starting point. Happy to see that we have got people who have been using C4 models and UML. That goes in line with. We also have software developers on this forum, which is great. And both combination of UML and whiteboard. So that gives a pretty good percentage of people using UML. That is really nice. Okay, and well, people might get sometimes stuck into the particular notation of the UML, but if you done right, UML is one of the best tool to capture the dependencies, get a view, the component views, the dependency view, the sequence views. So happy to see this. As we go along, we will try to link it back to one of these mechanisms of how you capture the architecture, which is very very fundamental and important. Also, what I will request is, the participants on this forum, we already have a partner solutions architect as a representative working with you. So please, as you go along, work with your PSAs on how you can better your ability to document the architecture. This is very very important as a partners, right? When you work with your customers, right, the longer relations, your ability to find new opportunities is not just only from a sales side, right? Also from a technical stability perspective, also from you to be able to advise, get into a technical advisory mode. You have to have a very good understanding of the customer's architecture. You need to have a good documentation. I have seen cases where customer would rely on the partner much more than anyone else, because the partner has a very good understanding of the architecture, the dependencies, the decisions, right? So it's not just one time activity, right? The continuous engagement and working in terms of understanding the ecosystem pays off in a very very long run. Okay, I'm just moving along. Take this quiz little off screen. And yep. So this is where the whole essence of well architecture comes in. Before that, just wanted to talk one more thing for the people who have heard for the term C4 first. C4 is basically one of the mechanisms. It stands for the context, where you set up the context of the architecture. You talk about the containers. The containers are not necessarily the Docker containers here. We are not talking of the Docker containers, but we are talking of something known as the modules, if you have to call it that way, right? Which gives you an overview of the system, and then you double click on it, you zoom in, and then you go at what are the different technical components, the technical architecture aspect of it. From a solution architecture, you kind of move to the technical components of it, and then you double click on that and you go actually into the code, right? This is something which is very important. And there is one more quiz that's going to come down the line, is that these things keeps on changing, right? You have the overall context, you have the containers or the modules, and you have components and the code. Code is something which is very, very fast. It keeps on changing, but it has the essence of architecture in it, and we'll talk about some of the best practices around that too. Okay, now why well architected framework? Well, there are two key areas we want to talk here. Okay, first is that whenever you are documenting an architecture or capturing an architecture, right, you need to have a consistent way of reviewing things. You need a way, how are you going to look at architecture, document the architecture. This need not be an academic exercise. This is a challenge, right? Many times we just do an academic exercise, one time activity, and nobody goes back and look at it, and things goes outdated. That becomes a challenging thing, right? So you have to have a continuous life cycle process over there. And this is the essence. A well architected framework is an enabler for you, and it covers the best practices of what Amazon has learned over a last more than a decade, working with the systems ourselves, right? The scale at which Amazon operates, right? So we have taken those best practices, the understanding of those things, and documented into a well-architected framework. This is not specific to AWS per se. We are happy to talk about this, saying that well-architected framework is a framework which you apply even to the workloads which are on your premises or any other cloud for that matter, right? These are the common set of principles that needs to be looked into, different lenses that you need to go through, and that is so fundamental to creating an evolutionary architecture, so that you are able to evolve as business need changes, right? It gives you a good process. It sets a consistency in terms of how we are doing it, and being able to ask the set of questions that we saw before, right? All technology portfolio related questions that you might have, that is important, right? The way well-architected framework is structured, you have got set of general design principles, which are paramount of how do you look at the system from a context perspective, from a component perspective. When you go down into specific areas, we look at the 5 pillars. They have their own set of design principles, and there are pillar-specific lenses that we have, or rather specific architecture lenses that we have based on the workload. So today in the session, we'll be covering serverless lenses. Okay, we also have IoT and HPC. If you've got any such workloads related to them, again, please feel to connect to the solution architect, the PSA's partner solution architect, and we'll be happy to help you there. Okay, this is very important. This thing, right? Don't this is sometimes a myth, right? Where you think that, hey, I'm using cloud. We all use cloud. We are using all the best practices of the cloud, but essentially the workload that is running on it, right, your the web applications or anything that you're running on it, right, it has to take advantage of the underlying platform, so to take the best practices and the design patterns, right? Unless those design patterns are leveraged, unless you have coded or configured in a specific way, you will not be able to get the best out of the platform that you are using, right? And this remains so true for anything, right from early 90s, where people used to write. So this is one of the things that I come from a software background, and I had a lot of discussions with people around me, and this is one of my very favorite phrase. I said, anything can be abstracted to the level of irrelevance, right? right? If you keep on abstracting everything, right, as a base class, I'm just talking from a object-oriented perspective, right? What do you put in your base class, right? This is what happens, right? When you want to abstract yourself so much that you start losing the relevance of things. That should not happen, and that is where the experience of the architects comes in, right? You need to design your system in such a way that there is a thin layer of a glue code which is taking the best advantage of the platform that you're running on, but at the same time you are not getting so abstracted thinking that, hey, what if tomorrow I have to move from this X platform to a Y platform? Hey, that's absolutely fine, you do it, but in that thinking you are losing the the best what the platform has to offer you. The glue code is important. Again, that's where architecture comes in, and as you're designing your application, as you're developing your application, you're thinking through the building blocks. It's important that you choose the right tool for the right job. Now, one of the best example over here is that you choose the right databases, right? Now, how many times you would have seen in your current or the past projects that when you have a hammer, everything is a nail, right? You would just use RDBMS for everything, storing relational data, storing graph data, right? Storing unstructured data. I've been on projects where we have actually taken 5 or 10 MB of an XML file and put it into a block, right? That's what we did, because it also had some images. Otherwise, we would use a CLOPS data structure, right? And then every time you want to go and retrieve it, do a filter and search, you are, if there are 10 concurrency coming in, you are kind of retrieving 10 MB into 10, like 100 MB of data from the databases. You are doing applying filter and search, and then customer or the end user comes and complain, hey, the performance is not well. And the solution that we say, don't worry, we'll just beef up the machines of the server. That's not the way to solve it, right? Use the right tool for the right job. Understand the application, and this is so important for the solution architects and even for the software developers to stand up and say, this doesn't make sense. Let's relook at it. What are the different options we have, right? So this is more from choosing the right repository or the right data sets. Even when you're designing your applications, these are some fundamental things around 12-factor application. I have heard people talking about 15 factors, but these are the essence of the 12-factor applications we'll cover here. What we want to say here is bring one very important fundamental mindset change, and that is so important. We need to start looking at the code base, right? And it's important that we look at the infrastructure as a code. Now, this is so important that traditionally we have been working as the code means only the application code. Infrastructure is something that is manually built and configured. Well, that's not the way in the cloud world, right? Everything is programmable APIs, right? Now, if you see on the 12 factors, I've underlined few things, and why I've done that is on a purpose, saying that, hey, this equally applies when you are just taking a mindset from an infrastructure or from a DevOps perspective, right? Everything has to be code. Why don't you use a cloud formation templates or a CDK to build your environment? It's so important. Version control it, right? We talked about architecture drift, right? We talked about how difficult it is to capture the architecture. We do it on a whiteboard, we capture it on a UML diagram, but ultimately the truth is what is there in the code, right? It does not matter how best or how beautifully you have drawn it on a whiteboard, or how good jazzy colors you have used on your UML diagram, or how accurate you were in using the right notation. Everything goes out of the window if the code doesn't match to what that is said. That's just the vision. The fact is always the code. And that is so important. And we always want that, okay, codify things, codify even your infrastructure. Identify what are the dependencies, declare them, right? Cloud formation, as it goes, right, the stack sets, and there are dependencies, it keeps on resolving, so that we know, okay, how are you going to assemble these Lego blocks together to form your architecture. Externalize your configurations, don't hard code them, right? Have a proper build, release, run processes, right? Automate them. Use right set of services to help you do those build, release, and run, right? Use the right computing model, right? Use concurrency. The microservices world is completely different mindset, but hey, you need underlying platform to support that. Use serverless. Again, look at what the application workload is, right? Not necessarily serverless is, it's not a silver bullet for everything, right? You have to analyze your workloads. Maybe you have to go for containers, and well, EC2 in itself is such a powerful thing. Not everything has to be containerized or you have to go the serverless ways. You have to go through understanding what is your actual workload. Just pay attention on those details, and you will actually come back to the right service models, right? Uh, uh, and this is more important for the DevOps team, is the disposability aspect, right? You all have heard of the thing like cattle versus pets, right? How once you have codified it, see, the disposability factor cannot be used efficiently unless you have got the reusable code base in place, right? Your ability to describe your infrastructure as a code, right? So they go hand in hand. Okay, and no one else more than the operations team will know the benefit of logs. Nobody wants to wake up at 2 a.m. in the morning to work on a particular sev one which has come in, right? There are best practices around here. How do you take infrastructure log, application log, and security logs? These are three important things, right? The DevSecOps, right? Start putting your mental model around the DevSecOps things. How you can correlate these things, what kind of automations you can put around that. It's a separate a session, a webinar, or a topic in itself, but these are just to get you start thinking in these directions. As you start working on the future architectures, think through these elements. Again, your PA, engage your PAs to help you take this further, right? What we want to do next is just take a sample case study that I will be referring to very often, is this one. This is not something which is very different than what you would have already seen in your environments. It's a simple web application, right? And in this web application, what we are trying to say is that you're migrated applications, right? You're using standard Route 53 for accessing the app. You got your standard DNS resolutions hitting the cloud front. You go to an ALB. You got your web servers. Again, your load balancers. You go to the application servers, and you got databases. Your static resources are stored in S3, right? So this is what I'll be referring to a couple of times as we go through each of these pillars, right? Next, what you want to do is quickly get into a specific areas of the design principles we talked about, right? Okay, how do we get started? Now, taking this as a reference architecture, okay, how do we apply the general design principles that we understood from a well-architected perspective to this? All right. The first and the foremost is stop guessing capacity. Now, this is for the solution architects, right? How many times you have been on a call where... sorry, I heard some echo for myself. Just give me a minute. Okay, continue. So how many times this, as a solution architects, you have been pulled into discussions, and the discussion happens, and then finally you said, what, hey, everything is fine. Can you just let me know how much will it cost me? I need a bill of material. All right, bill of material is good. I'm not saying that. You need to get started. You need to have some guesstimate, but don't get into the because if somebody has to sign a contract for like long term and put a sign on it, what you typically do, you over provision it. That's what anybody would do, right? In a traditional way. This is what exactly you want to go avoid, and say that, hey, let's evolve our architecture. Take that approach right from solution stage. Talk about how the days where you kind of put something in cast in stone, sign it on a paper, saying, hey, this is what it is going to cost you. And what you do is eventually, so again, that's a separate, discussion, which is TCO, total cost of ownership, and but the idea here is that you do not want to over provision anything right now. Stop getting capacity and use the right resources. What you want to do next is test your system at scale. We always knew of different environments. I've been on so many projects where the pre-prod environment, the test environment, the dev environment, they were all one. Well, in a very small cases, what you do is you carve out the same production box into separate user credentials and work on that, but then that's not going to happen. Now bring up your testing environments which resemble your production and test the system at scale, right? This is important that you are able to automate. Automation is important. Again, we talked about right from building your infrastructure to having your ability to respond to an event, whether it is an auto scaling event, your server is reaching the capacity, so you have got auto scaling group. You can use that, right? That's all automation, all about automation, right? You want to have an automation, even doing your automation, even doing your mundane regular tasks like backup, right? Your ability to take snapshots of the devices, right? Running some kind of a life cycle policies on the static contents, right? You want to move it from standard S3 to S3 Glacier. Automation is key important, and as you automate, you will see that it opens up an opportunity for you to do more experimentations, right? Experiment with different areas as you're working on a specific workload. And as your architecture evolves, most importantly, drive your architecture using data. That is so important. Sure that this is not just based on you feel good factor, but you have got hard data to say, okay, this is how my architecture should evolve. All right. So having gone through 6 basic design principles, we'll just move along and we will just talk most important part, which is about the game days. Right now, security at AWS or at Amazon is, we call it as job zero. Right, it's so important, so fundamental, and that is exactly the reason we will take security as first pillar from a well architected perspective, and also from any architecture perspective, which is important. Think about security from grounds up. Right, it is so important, and there are ways to find out security gaps, or harden your systems through game days. We'll talk about it in the next slide. Yeah, moving along to the security, and that's the first pillar. Is so what exactly we want to cover here in security? We want to talk about its ability for you to protect your information, systems, and assets while delivering business value. Right? You have done your risk analysis. You know what are the risks. You know what are the mitigation strategies you have put in place. Right? And to begin with, everybody has to understand one important thing, that security is always a shared responsibility, right? It is nothing, it's not one person's job. Yeah, every participants have to do their bit, right? Okay, and when we call of a shared responsibility model, it is not a security of the cloud and security in the cloud, right? So when we think about security of the cloud, that's AWS the responsibility to take care of security of the cloud, but security in the cloud is where the solution architects, the development team, that's the environment that you own it. You are supposed to secure the security in the cloud, right? Now, what are the best practices, or what are the design principles that you need to think through when you're looking from a security in the cloud perspective? So this has got two things. It has got design principles and it has got core services. So each pillar has got its own design principle and set of services. All right. Now, the first design principle for security is to have strong identity foundation. Right. That's so important, that you do not want everyone to have access to all the environments, to all the regions, to be able to do everything. First thing, it is paramount that none of them or none of the users access the root accounts. Root accounts are MFA. You create specific users, give them specific roles, and the ability to do just for what their role requires them to do. This is very important. You need to enable traceability. So for you to do any forensic, or for you to even trace in case of any security incidents, what are the other resources that might have got compromised? The traceability is very important. You have to apply security at all the layers, whether it is at the entry layer, whether it goes at your the auto scaling, or the data in transit layer, the data at rest layer. All the layers needs to be protected. It's not just the periphery that you need to think about. Automating, again, not all the security events can be automated. Like, say, for example, somebody went and changed the open up the port. So you got, an environment where you went, somebody made some changes to the environment and made that changes to security group. They opened up the port, capture those events, automate and close to have access. True, very important when you're talking regulated industries, for industry which are having heavy compliance and regulatory requirements. This becomes very important. And yes, you need to prepare for security events. This you have to link it back by, so you need to have a scenario. Please don't run game days on your production environment on day one. Please don't do that, right? Set up a separate environment, run those different scenarios, scale, test, and see how it is working, right? Have different scenarios. If, as people are working from home, they might want to have try something else. Why don't you organize something for some of the important workloads that you have right now? Have more game days. Ask people to kind of get into the system using different ways in a separate test environment, right? That's a good learning for the team. That's good learning for the even the DevOps team to automate so many things. The core services from a security standpoint here is IAM. Needless to say, everybody first uses that when you log into your account, and that's the first guardrail. That's the first thing that is important, right? Having set the foundation for the design principles and the core services, we now want to move our focus and understand from a security perspective what are the best practices in this area and what are the supporting services. Well, this is quite an exhaustive list. For this session, what we have done is we have tried and highlighted few services in bold, which you can get started with. So just for you to get started, if you already covered that, please feel free to go to the next level. Like from an identity and access management perspective, it's an IAM and please MFA. It's so important. We cannot emphasize any more than that use multi-factor authentications for logging into the system. For people who have already gone to that level, yes, you use AWS organizations and use STS. Don't use access keys and keep it in your app servers to connect to your other instances or databases. Use roles, use underlying those that uses STS, and it does an auto refreshing. So even if those instances have to get compromised, your blast radius is less. Because imagine if you have kept one of the access keys into an instance, and that instance got compromised and the keys got compromised, essentially. And if the role that has been given to that instance is much wider than what is required, it will have a higher blast radius, right? And we don't want to do that, right? And use those best practices around that, please. Finally, you just need some form of a mechanism to detect if something is going wrong, right? Unless you are able to detect, you won't be able to respond, right? Use CloudTrail for you to understand what is happening in the environment. Of course, CloudWatch is the second service that you will be using along with Cloud Config for that purpose. Sorry if any of these services is a very exhaustive list here. Any specific service, any specific design that you need, and definitely please get back to the solution architects or partner solution architects with you on specific areas, and we'll be happy to work with you on that things. On the infrastructure protection, this is very important. We talk about having set up your VPC. How many times have you started your production with default VPC? Now, I don't want to open a poll over here, but that's good for experimentation. On a production workload, please set up your own VPC, right? Start from ground zero. That's important, right? Make sure you have understood your CIDR blocks very well. You have understood, okay, if I'm going to integrate on premises, what are my CIDR range? How am I going to design my subnets? Does my subnet have sufficient IP ranges? Because as I start using more services, I will need those IP ranges. These are one-time activities, but they're so important, right? Have the right architecture, which we call as a landing zone, right? You may want to have separate accounts for separate things, like, for dev, you want to have a separate account for pre-prod, prod. Even within that, you might want to have different VPCs for workloads. Again, there are different permutation combinations that you can do, but idea is that set these things in as a foundation. They are very important from an infrastructure standpoint. Put a right kind of a guardrails in terms of the inspector, shield, and WAF, which is basically used for layer 7 protection. You come down to a data protection. Why we talk about data protection here is two things. Data at rest is, you have to encrypt your volumes, very important. Encrypt the data at rest, even in your S3. And, the ELB is all about configuring the HTTPS, it's data in transit. That's very important, right? Finally, on the incident response side of it, how do you respond to an incident is very important. In case of an incident, you need to have an automation where you are first able to isolate that particular instance. Isolation and disposability goes hand in hand. The moment you isolate an instance, or moment you isolate particular area, right, you don't want business disruption to happen. You want business continuity. You want to isolate that particular thing, use it at a disposable, fire up another instance altogether, and then you want to make sure that you then use CloudFormation templates to spin up another environment and run your forensics over there, right? There are a lot of services around here which will help you go more deeper into identification of services like Guard Duty, Amazon Detective, Security Hub, and Inspector, right? Having covered the security layer, we will switch gears and move into the next pillar of the well architecture, which is related to reliability, right? Now, when we talk about reliability, again, we will use the same sequence. What are the design principles and what is the core services? Any guesses here? What will be the core service for reliability while we go ahead? Okay. So design principles for reliability are testing your recovery procedures. Right now, what exactly we mean by reliability? You need to have an ability of a systems to be recovering from an infrastructure or a service failure. And this is so important. Everything fails all the time. That's how you will see Werner Vogel's talking about it at any of the forum, the CTO of Amazon, right? You have to think that things will fail, and how do you design in a way that when failure happens, how are you going to mitigate it? Rather than, if you see the traditional way of working, you would put as many BC servers as possible to see that failure doesn't happen. We were in the cloud. You think differently. You said, okay, it will fail, but how do I design in a way so that I'm able to recover from my failure fast, right? So you need to have a mechanism to test your recovery procedures. You need automatic recovery from failures. You need to make sure that you're able to scale the elasticity aspect. It is not just scale up, but also scale down. That's important, right? And you need to stop guessing capacity. Again, this has to do with the scaling. It goes hands in hand, and you have to automate these changes. The key element which will give you a view and lens into how to go and design this, that services is CloudWatch, right? Use your CloudWatch and CloudWatch logs to look at the different matrices and make those decisions for yourself. Okay, moving along, we have the best practices in these areas and what are the supporting services. Again, we'll go through the best practices. We have highlighted supporting services you can pick up and get started early on some of these things to get you rolling. First thing from a best practices perspective is the foundational area. And what we are telling here is that use trusted advisor. We have got a poll question there next, where we would like to know. But yes, trusted advisor is so important, and I believe you would have used it. If no, please go and use trusted advisor. It is the first level for you to have a well-architected view into your workloads. Right, you can start a free trial and then see what metrics are important for you and make decisions accordingly. Right, from a change management perspective, the AWS config that gives you understanding, okay, how your configuration are changing, how things are changing over time. You can have a lot of automation based on config changes and CloudWatch to help you with that. On a failure perspective, again, if there is an incident or if something goes wrong, you want your ability to reconstruct your environment as soon as possible, and CloudFormation is the way to go, where you will be able to build up your environment faster. Right. What we want to do now is quickly go through the next quiz. I'm just going to open up a quiz based on what we discussed on these two pillars, on the reliability and security aspect. Uh, just give me a moment and just open up another quiz. Here's one.
Hey Ravi, there is a
Yeah. Yep. Sorry. Just a moment. Somehow I got logged off, so might take a few moments for me to log in back. Give me a moment. Yep, I'm in. I'm just starting the quiz. So please use this and try to answer from your existing workload perspective. How are you maintaining these things? Second. Yep. What are the best practices the team is using right now from the security and reliability pillar? Kindly join the Zahut quiz. Yep.
Ravi.
Yep.
Yeah, this is Sonika here.
Yep. 1 second.
So there is a common question in the question poll on game days.
Yep.
So can you just address people what is game days and how does it help? So it's a
Sure, I
very
will.
common
Thank you.
question. Yeah.
Yeah, sure. I'll wait for 30 seconds. Okay, 5 seconds. Okay, opening up this. Okay, we have more participants joining. I'll wait for another 10 seconds. Okay, we'll start. Awesome. That's great. Thank you. That's nice, Harshal. Ankit. Okay, we'll go to the next quiz. Awesome. Great. Yes, it's IAM. It's the first guardrail that you put in place from a security perspective. Thank you. Not that other services are not important, but that's the key service because each pillar has got one key service, and as you will go along, you will see that every pillar of well architecture has got one service which we have identified as a key service, and then there are other specific areas or perspectives where different services would add on to it. Again, Harshal here, and we got Chinna coming in. Nice. Okay. Next question. That is great. So people have been so there are a lot of DevOps engineer over here, and yes, automation. If you got that piece correct, there is high chance that you will also get this because you want to automate even your security responses here. That's great. Okay, let's see here again. Harsh and China, great. Keep on going. Two more questions to go. Nice. Awesome. Great. From a reliability, it's for you to be able to have first. So again, follow this principle. If you are able to detect, you'll be able to do something about it, and that's why the key service here is a CloudWatch. Um, Great. We have got Ranson coming in. That's nice. And Ankur. There's two more questions to go. Great. And people got it correct. Yes, you need to make sure that you're able to set your service limits properly and get your network topology correct. I will quickly talk about service limits. Yes. Oh, great. We have got Rahul coming in. Nice. And Ransom. Last question coming in. Awesome. Yeah, great. More than half people got it correct. Yes, you have to follow all the principles. Uh, that is awesome. Thank you, team, for joining in. Let's see the final score. Rahul, congratulations. Then we got second position Raju, and no guess is here. Ankur. That's great. Thank you. And we got runner-ups Prabhakar and Paya. Thank you. Congratulations. We'll continue with our sessions. Uh-huh. Just give me a moment. Yeah. So before we go to the next slide, there was questions around game days. Right now, game day is just a mechanism. What we are saying here is that with your teams that you have right now, any workload that you think are important, right? Please, again, I cannot emphasize more than this. Never ever do any of these things in your production environment when you're doing it. Okay, the likes of Netflix have mastered the arts of doing it in their production system, but they have taken years to reach there by using Chaos Monkey and so many other things. But to get started, the philosophy around game days is that you create a simulated environment. Like, say for example, you got a web applications right now. I'm just keeping it simple right now so that it connects with everybody in the crowd, but it can be a complex workload. It can be a DML workload which has got data pipelines. It can be an IoT streaming Kinesis workload. But what we are trying to say here is that in a test environment, right, spin up those things, right, and have different team members, especially cross-functional. Like, say for example, let the dev team think about the ops, let the ops things about the dev, right? And also create a different scenario where you try to see, okay, how you can stress the system out in terms of performance, how you can break the systems in terms of security, how you can make sure that even if it breaks, is it able to reliably scale. So all those 5 pillars of well architecture. Of course, cost is something that will be the outcome of, okay, how your system is scaling. There are trade-offs that will come out of that. But what we are trying to say is that as you create different scenarios for your applications that you want to test, right? Like, it's a web application. I want to see, hey, is I'm getting it redirected from my DNS to my CloudFront, but is my web server still open? Right, if by some way I'm able to find out, and I'm going to hack into my view source code of my browser and get a URL, right, is it that I'm now able to get directly to my web server instead of going through my CloudFront? Some of these things, right, the best practices that you need, these things will then help you scale, protect, and optimize your system accordingly. There are multiple scenarios that I can talk about, but idea here is that each team is coming up with a different scenarios. Each team is coming up with a different aspect where they are trying things out and seeing whether it is the way it is, whether the system is performing the way it should, and also if there are any misconfigurations in the systems, right? Say for example, just go and bounce off your server, right? See if what is the impact on your application. If it is not in an auto scaling, you will see there is an impact on your system, right? Just kill the server and see is how much transactions are you losing, right? If you have not externalized your session, and if the server fails, well, that user loses his context, even his work which is in progress, because that may not have been saved. So these are different failing scenarios that you want to try out in your game days. Any more questions? Happy to answer that. Keep those answers coming in on the chat. Moving along from a quiz to the next pillar, where we're going to talk about operational excellence. Right now, in the operational excellence, what we want to do is same sequence that we will follow when we look at any of the pillar. Is their ability for your systems for you to monitor your systems to make sure they're able to deliver the best values. Right now, from an operational perspective, it has got its own set of design principle and a core services. Again, every pillar has a set of design principle, has a set of core services, specific areas and services we'll talk about, right? From a core design principles, from an operational perspective, this is very important to have perform your operations as a code. How many of you have thought through and played with your run books and playbook? Okay, now each of these things matter very important when you have to perform your operations at the code, especially from a run book perspective, which is more about your planned activities that you want to do. You want to take a backup, you want to take, you want to, drain some connections, the stale connections sometime happen, you want to clear up the cache, right? Some of these things that you do as a manual activity, why don't you automate it? That's more of a planned activities that can be automated in terms of a run book, right? There can be scenarios where you have got unplanned activities, and these unplanned activities are more about your playbook. Where system fails, how do you diagnostic it, right? So you will have those set of sequence and steps, standard debugging procedures, but there is no one way to do it. It's based on the judgment, it's based on how the system is behaving, and that's where you will have more playbooks coming in. Playbooks can also be part of your game days, but they are not exactly the same, right? From an operational perspective, document annotation. Now, why we call this is that if you have done your infrastructure as a code and you annotate things properly, then it will basically help you understand which environments, which area, which tagging, which resources are having challenges, and how do you isolate them. All right. Again, piecemeal approach. Make what we recommend is that makes frequent and small and reversible changes. The reversible is very important from this perspective, so you're able to roll back. Even from a service release perspective, we would have all of canary builds. We want to have different channels, the alpha channels, the pre-release or pre-build series, and all of those things. Right, you need to have your operations to be refined at a frequently. So have a look at your operation procedures, see if you can automate them, anticipate failures in your operations, and again learn from your operational failures. This is so important. From a document, for most of the partners that I always interact with you, knowledge management is here important. Knowledge management is not just updating the wiki and forgetting about it, please. Knowledge management is okay, how a collective as a team has understood things, and you have also gone and automated those things or updated things which are done manually into an automation. It can be anything. It can be a cloud formation, it can be CDK, it can be Terraform. That is absolutely fine. But this is just one time infrastructure provisioning. But after that, you've got a lot of operations that you want to do. You can have small Lambda functions to help you with clean up your logs and many things, right? So each learnings that you have from a failure, please document them and find out, work with your team of how you can automate them. The good part about the partners is that you will see that if you are starting doing some automation for one customers, you will see a common pattern that you can have your IPs built and used for other customers also. That is the value add you can provide, right? Any guesses on operational excellence core services? Here it comes. It's cloud formation. No guesses here. You should need to have an ability to spin up your infrastructure as soon as possible. Okay. The best practices from an operational pillar perspective and the corresponding support services. You need to be able to prepare yourself from an operation standpoint, prepare for any operationals priority that might come, readiness perspective. Use AWS config rules. They are such a good thing. It can be used to look for any changes. Like, unless you know what was the baseline, you will not be able to remediate it or make an informed decision from an architecture perspective, right? And that's where AWS config becomes very important. If you have used this AWS config service, you will see that it gives you a timeline of when was the config change, what was the timeline when it was the config rule compliant, non-compliant, and any event or reason why it became non-compliant. It's very important from your architecture perspective to see what is happening in an infrastructure. Once you have done those preparations of configurations from an operations perspective, you can then look at your CloudWatch and see why those drifts happens, what are the health of my systems. This will also help you understand any business insights. Like you will definitely see that, okay, while I've configured certain aspect of my system, like maybe from an auto scaling perspective or from number of even from a bandwidth perspective, or if you have got a VPN or if you have got a DX, right? These are very, very important things because it will give you an insight into your business cycles, right? You will see that maybe some workloads have got different peak requirements. They have got different needs in terms of storage, compute, or bandwidth. This is very important. As you operate, if you create those standard baseline, and then you will be able to respond to these events in case of how to remediate it, or how do you compensate for any loss that is happening during the working business hours, is by having a standard set of runbook and a playbook, right? And yes, you need to evolve. The learning is important, the knowledge management and continuous learning. And for you to understand the learning, the key service why we call Elasticsearch is that what you do is you take your application logs, your infra log, your security log, and and this is more important, the application log, right? Because everything revolves around the business users, what applications they are using, right? And for you to do your continuous improvements, right, you need to have a view of interdependencies of your business use cases, and that is why this concept of microservice is very important, right? You know that which particular service is more important for you. Say for example, standard payrolls, you will see that towards the end of the month that becomes very important. All of a sudden, with work from home, you will see the chat and email. Those services have gained more prominence, right? So this evolution and insights happens not just by a guesswork, but again we say data-driven decisions. And for you to make those data-driven decisions, it is important that you kind of go through each of this, correlate, and have insights into these services. Okay. This is done. Moving along to the next, which is performance efficiency. Now, what we mean about performance efficiency here is your ability for your computing resources to effectively meet the system requirement, right? Now, how do you make sure? Again, this is just give me a second. Hold on. Sorry, my network was a little patchy. It showed me a red icon, so I just paused for a second. Yeah, back. So from a performance efficiency standpoint, it is again, the how are your compute and your resources able to meet the requirements, right? And are you able to maintain the right efficiency as the demand changes, right? Now, the key point here when we talk about performance efficiency, even right from a design principles perspective, is mechanical sympathy. Now, how many of you have heard of this word before, mechanical sympathy? Now, this is about making sure that you are using and you're understanding the system the way it should be designed, so that you can align your business goals and have an optimal price performance ratios, right? Now, example that I can take here is that if you have got a bad job, right, a long running bad job, which is like taking 10 hours for you to run on a particular instance type, right? Okay, if you use a higher instance type and if you're able to run the same batch job maybe in an hour time, right? From a cost perspective, from a time perspective, from an efficiency perspective, if you do your calculations, you will see that it's okay to put that bigger instance for an hour and get your job run faster. This is important. So understanding is very important. So it is using again, coming back to the same concept, using the right tool for the right job. Okay, that's one. Second, using the right instance type, right configurations. There is a very nice example that I kind of understood about the mechanical sympathy when I was seeing one of the documentary on Formula One. So it was a very interesting documentary about Ferrari and how they build mechanical sympathy. And one of the very interesting thing the engineer there told, he said, we can make car as fast using technology as possible. It's a driver, right, who exactly knows which control, which lever to use at which curve to overtake this competitor, and it's split second decisions that driver makes, right? So he has got all the controls to make those decisions, but still the driver has to make those decisions, right, in those split seconds, right? And well, we are not in a racing here, but again, the concept is still the same. The sympathy, right? Even if you've got the best machines to use, unless you understand the limits that you can push each parameters up to, and how you use a combination of these limits to build your system, that is an essence of performance efficiency, right? Moving along from here, let's get more into design principles. What we are saying is democratize advanced technology. That's the first thing we want to say, right? If somebody had to think about say for example playing around with machine learning and try to build their own models. They needed huge machines, right? They needed huge infrastructure to build. Today you have got sage makers to get you started early. You have got high instances, GPU instances to try your things out. So what we are saying is the technology is democratized. You have got access to the same technology or the same instances that any other organization would have. So feel free to go and experiment and learn and think about mechanical sympathy. That's the whole essence behind it. Okay, your ability to go live in minutes. Again, that's again linked to your part of experimentations, and then go live in minutes, not just in one areas, but as your workload expands across different geographies, right? Use serverless so that you are able to focus more and more on the business functionality that you want to deliver, rather than being spending too much time in configuring, maintaining. Again, coming back to the same pets versus cattle mindset, right? So this is where let the foundational work be taken care by the infrastructure, and you can focus more on your applications, right? And what serverless means and does not mean will be covered exhaustively by Tushar. We'll have that. We want you to experiment more often, and make sure you apply a mechanical sympathy. Any guesses around performance efficiency here? Yes, it's CloudWatch, because for you need to have visibility on how your system is performing, right? What are the key best practices in this area and the supporting services? First, you have to make sure that you are selecting the right services. We talked about it, the example of a batch job with the right instance. Yeah, the key service here is auto scaling. Again, we are talking about S3 for you to make sure that uh, you know use it properly, so that you select the right data store for the right thing. Couple that with the right security configurations, which is very important. You need to make sure you have a mechanism to review your performance, and this is not about application performance. This is about mechanical sympathy, right? Now, if you have to have a mechanical sympathy, what we are saying here is that new releases, new feature keeps on coming, right? It's like a Ferrari getting an upgrade, right, at a very high speed. It's Ferrari and end of the day, right? So if you understand those features of the car, the features of the platform, the better you can then leverage